So this video is going over questions 11 and 12 from lesson 4F. So let's start off by looking at question 11. A model rocket is launched straight upwards with an initial velocity of 200 meters per second. The height of the rocket, h, in meters, can be modeled by the equation h equals negative 5t squared plus 200t, where t is the elapsed time in seconds. What is the maximum height the rocket reaches? All right, so to answer this one, what we're going to do is we are going to start off with our equation. H equals negative 5d squared plus 200t. So the maximum height that the rocket reaches, we know, would be our vertex. So what we want to do is change this equation into vertex form. We could see this equation imagined like that too. If you wanted it to look like full standard form. So we're changing from standard form into vertex. And to do that, what we do is we complete the square. So let's go about doing that. So we're going to take out our factor of negative 5 here. Oops. Minus 40t. Alright, now what we want to do is we want to complete the square. So we are going to we need to find, basically what we're going to do is we're going to half this number and then square it. So half of this is negative 20. Negative 20 squared is positive 400. And what we do to the inside of the brackets, we also have to do to the outside. However, on the outside, we have our negative 5 here. So we have to multiply our opposite here. So 400 inside, we're going to be minus 400 outside, but we're going to times it by negative 5. I'm just going to put that in brackets for now, so I can remember that I have to do that. Okay, so let's go ahead and do that then. So negative 400 times negative 5 is 2,000 plus 0, so just 2,000. Now what we're going to do is put this into our factored form here then. So negative 5 is going to be t minus 20 squared. Alright, so now we can see that this then is in our vertex form. So we've changed it from our standard form to our vertex form. And we know how to read our vertex straight from our vertex form, our vertex. Our vertex here is h, k. So we can say then, we know that our k value here would be our highest point, our y value of our highest point. So that then would be our height. So that means that we can say that our max height is 2,000 meters. All right, let's look at the second question then. Question 12. The cost, C, in dollars of operating a concrete cutting machine is modelled by this equation here, where n is the number of minutes the machine is run. How long must the machine run for the operating cost to be at a minimum? What is the minimum cost? Okay. So, again, we start off by having our equation. Alright, so whenever I'm talking about a minimum or a maximum, we're always talking about our vertex. So again, what it's asking us to do is to change our standard equation here into vertex form and find our vertex. So we just again go through our motions of changing and completing the square. So we're going to take out our factor of 2.2 and we're left with minus 30 and plus 655. Alright, so now we have to make a perfect square on the inside of these brackets. So we're going to take half of this value here, which would be negative 15, and we're going to square that. So you add 225. So whatever you do inside the brackets, you have to do the opposite, equal and opposite outside the brackets. But then remembering we have this factor in front. So we have to times it by the factor in front, times negative, it's the opposite. I'm just doing this bracket so you can see step by step what we're doing here. I'm going to quickly finish that. That should really be a plus. 2, 5. Alright, so 2.2 times negative 225 is negative 495 plus 655. So you can do that now. Is 160. Alright, now let's factor our perfect square. And we get n minus 15 squared plus 160. Again, we can see now we have it in vertex form. So we can see that our vertex is 15, 160. Alright, so from our vertex form, we know that n would be the number of minutes the machine is run, and c is the cost. So from our vertex we can say, okay, so the amount of minutes, or the cost is minimized when the machine is run for 15 minutes, and it would cost $160.